our series, webinar series, excuse me. We are having a conversation about filtration today, and we didn't want to do this completely on presentation style. This is going to be a Q&A. We compiled what we believe are the most common questions that we've been hearing of late, and it's sort of the everything you wanted to ask about filters, but we're afraid to ask. A couple of housekeeping notes. If you hover your mouse over the image and select speaker view, that's probably the optimal viewing option for seeing this, as we're going to go back and forth with speakers. We are not going to bore you to death with a PowerPoint. We're going to get to right to the meat and potatoes of these questions. And then if you want to post a question on Q&A, we will try to get to all those questions as we go through it. We have some preloaded that we know are hot that we want to get to. And go to the Q&A, and we'll get to all those as time allows. So to do this, we're going to have, we have two filter experts here with us. So first off here, we have Joe Randolph. He is presently Director of Distribution Sales for Camfil USA, who is absolutely a leading manufacturer of filtration solutions. These guys are involved in air pollution control. They're involved in building filtration solutions. They're involved in molecular contamination control, and they are involved in filtration to the power industry. They've done just mass amounts of work in commercial buildings, data centers, hospitals, life science, food and beverage, manufacturing, K-12, and higher ed. Joe brings 30 plus years of HVAC experience here. I do want to point out an interesting fact that Camfil was part of the successful Pathfinder mission to Mars. They had 6 of their ventilation filters were selected to be installed into the land rover, into the lander and the rover as it went on the surface of Mars. And it had to be incredibly precise in the filtration so that we didn't cause any contamination on the surface of Mars. And so we have Joe Randolph here to answer the majority of the questions we're going to fire out at him. And then also joining us is Chris Gurman, who is one of their leading distributors in both knowledge and in sales. So he is with a company called Thermal Recovery Solutions out of suburban Atlanta. They are a representative and reseller of specialty electrical and mechanical equipment for commercial and industrial HVAC. They specialize, as it relates to our conversation today, in air handling, air filtration, energy recovery, humidification, laboratory control, specialty sensing, measurement, and ventilation. And then highly qualified to ask questions is myself and Dan Deal from Aircuity. So we are tied into this because Aircuity, if you're just not familiar with us, in one sentence, we are a solution provider that installs hardware and software into buildings that will ensure that you are providing for your tenants or employees or students, whoever it is, the absolute optimal and most healthy air quality in that building, integrating that to any system you have, and then communicating that to all involved stakeholders. So thanks, guys, so much for joining us on our webinar series. I'm going to dive right into it here. High-level question that I hear people ask or are afraid to ask or misstate all the time. Can you please explain what is Hepa filtration?
Perfect. First and foremost, thank you for allowing me to be here today. I'm really excited to participate. So Hepa filtration is high efficiency particular arrestants. So that would be a particle capture at 0.4 microns that achieves an efficiency of 99.97% capture. So high efficiency particulate arrestants.
Okay, so Hepa can be either fiberglass, pleated. I mean, it can be of different media. Is that correct?
So there's basically 2 or 3 types of medias out there. So, and primarily you can have an aluminum separator, you can have a V-bed type or a mini pleat type. So the majority of that product out there is a wet laid fiberglass. And then they have a PTFE media also. And a PTFE media is used in microelectronics because we can't off-gas boron into microelectronics. And then there's another hybrid media that we have just came out with that's called an EnerGuard media. So basically there's 3 products that would go into a Hepa filter.
And the Hepa then just achieving the distinction of the exact size of the particulate that you are stopping.
Correct. And so HEPAs are certified by IEST, and then our normal filtration, which we would call Comfort Air products, it's certified and maintained by ASHRAE.
And what is IEST?
International Environment. Oh, God, I knew you were going to ask me
Oh.
that. It just bounced off my head. I went brain dead here. So I'll get back to that question.
Okay, but it is the governing body that is certifying as to whether or not what is
Correct.
what is or is not HEPA.
Correct.
Okay, got it. Dan?
So I guess sticking with acronyms there, Joe, could you also then explain Murph?
Yes, so Merv is the minimum efficiency reporting value. And that is mandated. How you get a Merv value is through an ASHRAE 52 test chamber. So there's independent facilities that do this testing. And also we have manufactured 3 of those labs worldwide that we do our own Merv rating test. And that's governed by, once again, ASHRAE, American Society of Heating, Refrigeration, Air Conditioning Engineers. So the most current standard right now is ASHRAE 52.2, 2017. That's the document that we adhere to. So also in that is there's a Merv A value. So Merv value would be the efficiency of a filter brand new out of a box. And then the Merv A value, some products that we use and other manufacturers use have an electric charged media. And what that does is it gives it a higher efficiency by electrostatically charging that. So to get the Merv A value, it's the same test chamber that you use, except you use a potassium chloride to discharge that media. And then it gives you what that Merv value would be throughout the life of that filter. So usually charged medias will decrease in efficiency over time. So one of our recommendations is that the Merv A value is really the Merv value that you want in your facility.
I just got from Kevin Delahunt, IEST, the Institute of Environmental Sciences and Technology.
Yeah, that's it. I was going that way with it. Yeah.
Thank you for the clarification.
Can I jump in about the Merv ratings?
Please.
Sure.
Back in the day, filters used to carry a percentage of arrestants. So you would have a 30% filter, a 65% filter, an 85% filter, or a 95% filter. And those tests were quite vague. So they changed the testing to the Merv rating to put more teeth into the actual value of what size particle can be arrested by a filter. So a Merv 8 filter traditionally was considered a 30% ASHRAE filter. A Merv 14 filter is considered a 95% filter. The Merv ratings are much more defined, much more prescriptive. But if you're speaking with someone of a building owner and they say, I want a 30% filter, they typically want a Merv 8 filter or Merv 8A filter. If they want a 95% filter, typically the slang is they want a Merv 14 or a 14A filter. And we try to steer all of our customers toward the Merv A rating because much like much like tires on your car, you don't want your car tire to be rated for a certain miles per hour, and then after it's been in use for a month, the tire be derated to a lower speed. That's the same way, or gasoline for that matter. You put in 93 octane, you hope after 2 months it's still 93 octane. Same thing with Merv versus Merv A. Merv A is the actual life arrestance of the filter, whereas Merv without the A is just the initial arrestance rating.
So almost completely irrelevant. Like, if you're intending on using this thing for a while, Merv A is the criterion you want to drill in on.
It should be with anyone who cares about controlling particulate or protecting spaces or protecting people. Merv A is the more rigorous standard.
Okay. And good. So ultimately what we're doing is we're trying to arrest particulate. We're trying to figure out what's exact filter specification do we need to arrest what particulate. And then just as a clarification here so that everybody, I'm not sure the technical level of everybody online, but you hear the term PM 2.5, PM 10, and PM 1. So Joe, would you just give us a real quick few sentences on what in the world is PM 2.5?
So that would be particle matter at 2.5 microns. So just to give you an association to a micron, the average diameter of a hair follicle is 50 microns. We can visibly see to 10 microns. So when we talk, the EPA talks PM 2.5 or PM 10, they're talking about 2.5 microns or 10 microns.
Okay, got it.
And then PM 1 would be the category we start talking about submicrons. So that would be 1 micron below. And that's what 99% of the air is made, particulates in the air are made up with 1 micron or below.
So I'm trying to keep, I'm operating a commercial building and I'm trying to keep it as healthy and safe as possible. What PM should I be worried about?
So particle matter PM1 is the most detrimental to the human body. So if we look at the recommendations from CDC, their new recommendations are a Merv 13 product. If you look at ASHRAE's recommendation are a Merv 13 or a Merv 14 where possible. They have a couple documents on their organization that you can download for free. And one of them would be a new document. It's came out of their epidemic committee, and it's on filtration and disinfection. So it has a 35-page document, and they actually reference Merv and Merv A in ISO EPM1, PM10, and EPM 2.5. And then also they have a document on, a position document on airborne infectious diseases. And that's been reaffirmed in February of 2020, and that runs through August 20th of 2020. So those are 2 free documents of resource, and I really recommend everybody go to ashrae.org and download those free documents.
Good stuff. I guess the next question we would have is, or maybe many people are thinking about, is why not just go to the highest level of filtration you possibly can get?
So yeah, that's our recommendation as well. You know, so our recommendation is a Merv 15A product to best mitigate risk of airborne infectious disease. But really you have to rely on your HVAC specialist or contractor to ensure that that air handler is able to overcome the additional external static pressure that's going to be put on the system. So secondly is that not all hardware within your air handling or your HVAC equipment is able to be upgraded. So you may just have a 2-inch pleated filter slot. So that creates problems. So you would have to do a hardware retrofit to be able to go to a higher efficient product in your facility.
Question came in, what is a ULPA filter?
So that's an ULPA filter, and it's ultra low particulate arrestant. So when you look at a Hepa filter is categorized at 99.97. So you can get an ULPA filter, which is a 99.9995. So we can go up to 5 nines in that whole process. And an ULPA would be an ultra particulate filter. So that's a different grade, and it's used in ISO classifications for clean room. So when we start looking at ISO 1000 in an ISO 10,000 clean room, that's what we're dealing with ULPA filtration there.
Okay.
Typically, people ask us locally, ULPA or Hepa. The answer is unless you're making some type of microelectronic device, you're making a printed circuit board, chances are an ULPA doesn't have any value for you and your process. Typically, the particle size is so small that it affects a wafer, Intel processing chip. That was really the driving force behind the ULPA development. So if someone asks, hey, should I use ULPA because it's better? The answer is usually no, unless you have a very specific need for arresting a very specific particle size.
I have a question that just came in here. So just flipping back to Merv for a second. So Merv, and this is really cutting to the meat of what everybody wants to know about. Merv 13 is minimum for new California Energy Code projects. but looks like Merv 14 best for COVID-19 reduction. Would you comment on that, please?
So yes, if we look at the ASHRAE documents, inside the ASHRAE documents is a Merv chart. And so there's, inside that Merv chart, there's 3 ranges. There's an E1, an E2, and E3 range. And E1 is 0.3 to 1 microns. And when you're testing, it tells you the percent capture in that range. Along with E2, E2 would be 1 to 3 microns, and then E3 would be 3 to 10. So at a Merv 13, you're capturing 50% particulate at 0.3 to 1 micron. At a Merv 14, you're catching 70% over 70%. So you're increasing your efficiency. And then when you go to a Merv 16 product, you're up at 95% capture at that 0.3 to 1 micron range. So when we talk about Merv 15 products, we're talking at capture rate above 90% in the E1 range, which is 0.3 to 1. And that's where we really find the risk value of that COVID-19 is that it's 0.01 micron to 0.25 microns in size, but it needs some type of water nuclei to adhere to become airborne. To be airborne, we're looking at 0.5 microns to 3 to 5 microns in size to be airborne. So we need to really start filtering that air. It has to be in that E1 range of 0.3 to 1. And like I said, at 50% efficiency, that's a Merv 13 in that 0.3 to 1 micron capture.
So,
Tom,
I'm sorry. Go ahead, Dan. I was just scanning through some of the questions. Go ahead.
Yeah, you're scanning the questions. I guess a logical question, a lot of acronyms here. We're going to be describing everybody, but again, one of the questions that was asked is who does the ratings? Is there a uniform standard like UL SAE? I think we already answered that with the, is that the ISTE, right? You touched on that earlier.
So for the Comfort Air products, it would be ASHRAE, right? But also there is a UL 900 listing, and that's the fire retardant listing of an air filter. So you have ASHRAE and then you have UL testing as well. So all Comfort Air products, meaning products that would go in a commercial building or a hospital, is also tested through UL to have UL approval.
Got it. And Tom, I guess I'll just go because I mean, following on the COVID conversation that we just talked about. So you kind of touched on this, but can a building air filtration protect me from getting COVID-19? So you just want to just elaborate on that just a little bit, just to directly answer it?
Yeah, and I'll bolt on top of that question, Dan, a question that came in, which is, so what is your hardware recommendation for increasing the levels of Merv 15 from, say, a Merv 13? So what is your recommendation for, prevention of the spread of the infectious aerosols, and what is your recommendation in terms of increasing the hardware levels?
Right, so we'll start out with the spread, and it's about air changes an hour. So definitely you want to be able to maintain good air changes an hour. If you're only getting a couple air changes an hour, we still have to get that particulate airborne, and it has to go through the filter for it to capture. So we have to make sure that the HVAC system is functional, it's maintained and running properly to get the recommended air changes per hour by ASHRAE standards. And then for the hardware itself, the unit comes with a set prescribed design. So if it has a 1-inch track in it, we want to make sure the integrity of the hardware doesn't have any bypass, that the filters themselves fit snugly and tightly in the system. Because if there's a 1/4-inch bypass in a 24 by 24-inch filter, that equates to 18% air bypass past that filter, or cutting a 3-inch circle hole in the middle of that filter. So we want to make sure the integrity of that hardware is correct and no bypass. But secondly, if you have a 2 or a 4-inch track, then you can either buy hardware from an air filtration manufacturer, or you could have a mechanical contractor make a hardware retrofit system for your air handler. They have many different types that can come with. They're type 8, there's fast frame holding frames, but you have to make sure that you're going to get the correct foot per minute and velocity through that, and you don't overrate that velocity for the means of the filter. So you can get good Murph 13 to Murph 15 to Murph 16 filtration with a 1-inch header, or a Type 8 header, or a fast frame header. And also, it's difficult if you have a V-bank configuration. Typically, that's you're limited to a 1, 2, or a 4-inch pleated filter in that situation.
So lay a summary of that on me. So you want to make sure that you're at least at Merv 14.
So ASHRAE's recommendation is Merv 14, where applicable.
I'm saying for kind of, let's call it COVID avoidance.
So COVID avoidance, so that gives
14.
us good capture rate, right?
Okay.
So our recommendations are Merv 15.
Merv
But,
15, I'm sorry,
but
Merv
also,
15.
So with a 1-inch track, if you're not in a hospital situation, because the hospital standards are different, especially for patient care, it's required to have a pre-filter before the evaporator coil or the chilled water coil. And your secondary final filter, based off of ASHRAE standard 170, has to be downstream of that heat exchanger or the hot the chilled water or DX coil. So, but in a commercial application, you can put a 1-inch track prior to the DX or chilled water coil or hot water coil, and be able to use a bag or a pocket filter that would achieve Merv 15, 15A efficiency to be able to protect that building. Okay. So it's just, it's calling your filtration expert in there and having him do a survey or an assessment of the HVAC equipment to ensure that that upgrade could be sustainable.
Because, for example, I'm sorry, Dan, go ahead.
So in a nutshell, so if I have Merv 8 today and I want to upgrade that, basically I need to validate the current configuration and see if it can, both the system, the rack and everything else can handle the new filter, and also that the system can handle it as well.
Correct. You have to make sure that you have the horsepower available to be able to maintain that CFM and static pressure within the system.
Got it.
All right. So
can I jump in on the COVID risk and being in workspace? So what we know is that we as humans are the aerosol generators for COVID. It doesn't just hang out outside in the sunshine waiting to sneak into your building to jump in somebody's body. The risk profile for COVID is being in the same space with someone who's unprotected, who has the COVID virus. The virus is very contagious. However, it is not very resilient, which is why you see the success rate that we've had with cleaning spaces, better hand washing, and face coverings. So the concern is if I go into a building and someone has COVID, statistically, if you're nowhere around them, there's little to no chance you're going to get it from them. However, if you're in the same room, say in the same cubicle farm, and they have it, you have a very high chance of contracting it from that person who is in your personal space. If you talk to most hospitals, they will say, as long as you're not in the wing that has the COVID patients, traditionally you are not going to get COVID from the non-COVID wing, which is why we're starting to see hospitals open up. Hospitals also have a layer of protection on their conditioned air that most homes and offices do not. But the main risk profile for getting it is person-to-person transmission, not person-to-environment and environmental transmission. Does that I hope that addresses the previous question of how safe is my building to go back in? The filtration requirements are our recommendations, and we say that all filtration is a compromise. A brick wall is a wonderful air filter, but the brick wall has a very high pressure drop. So if you've got the fan capacity, you're better off using a higher quality, higher arrestance filter. If you don't have that capacity, you are going to limit your air change, which is a compromise. You're either going to limit air change or you're going to reduce the amount of heating and cooling you can provide to spaces. So it very much is a compromise, which is why we always recommend, if you're going to engage in that type of decision, a professional engineer is always your best course of action.
How do I know, or how do they determine if my system has the capacity?
Great question. There's two capacity questions. One, do you have the hardware to support upgrading your air filters? And two, do you have enough fan horsepower to overcome the resistance of the added resistance? So if you have a 1-inch filter track, you're really not going to have a good time going to from a 1-inch filter track to a 1-inch Merv 13 filter because the resistance is too high. If you have a custom air handling unit with plenty of space between the rack and the coil, and you've got 22, 25 inches of space, you can very much convert those pre-filters from a 2-inch pleat to a 22-inch deep bag and probably be okay on the pressure drop. It really is a compromise. The one question we've gotten through all of this as a distributor is contractors and customers come in and say, hey, I got a rooftop unit, I want a hospital grade filter, or my residential unit, I want a hospital grade filter. Well, you can't simply do it because those systems have a predetermined fan static pressure range, and you can't adapt those higher efficiency filters to those units without degrading the flow performance. So it is a compromise. The other nice thing about hospitals is typically they have very large, very maintenance-friendly mechanical systems, so they can usually accommodate going from a 2-inch pleat to a 22-inch bag because the air handler was built like that from day one.
So what? So you addressed rooftops and homes or something like that, but what about large commercial office buildings?
It is very much dependent on what is currently installed.
Okay.
Most of our sales staff here locally are going out and surveying equipment for UV, surveying for filter performance, surveying for filter availability to add more filtration to air handling units. It requires someone who knows what they're looking for to go out and survey equipment.
Chris, talk more about the UV. So what are you surveying for there? What are you recommending there? How does that augment your filtration?
Historically, we have sold UVC, which is a very finite range of UV lights, to provide cleaning to cooling coils. Because if you've got a coil and it's wet, it's dark, and you got particle matter, it can grow stuff. So we apply UV to kill the stuff growing on coils so that heat transfer remains and air pressure drop remains original equipment. The second topic that we talk about in UVC is called airborne kill. So airborne kill is a function of how many watts per square foot, air speed, air temperature, and reflectivity of the cabinet. Whenever we get into an airborne kill, the question is what do you want to kill? And what are your design conditions? How cold is the airstream? How much space do you have? What's the CFM? So again, it's an engineering formula to determine how much UV you need into an air handling unit to determine what you want to kill. So that's it. There's two layers of it. It's either you want to put enough in to make sure that you kill what's going to grow on the coil from a heat transfer standpoint, and that's very well prescribed in the ASHRAE journal and the ASHRAE application guide. And then there's airborne kill, which is a much more scientific approach and requires someone to actually know what the conditions are of the exact piece of equipment to size a UV light array to provide airborne kill.
And just so I'm clear, the airborne kill is as the air is flowing through the airstream in that duct, you are, if there is, for example, COVID in that airstream,
correct,
killing it as it blows by that UV light.
Correct. And the good news is there are currently professors, staff, research scientists trying to determine what kind of a residence time or what kind of conditions do I need to kill that specific component or that specific virus. Well, it's not kill, but render it unusable.
Unviable, yeah.
There you go, sorry, unviable,
Yeah.
Great.
And then one last question on that UV thing that came in from the group. With the use of UVC technology at return assemblies, how easy is it to get Merv 14 natural fiber filters that will not deteriorate with the UVC?
Great question. Polyester or synthetic media do not hold up well to UV, and I'll let Joe talk about the fine fiber products hold up well. I know there have been concerns over the urethane binders that hold the media into the filter packs themselves, but I'll let Joe talk about that.
Right. So yes, we've seen UVC or UV lights in systems for, God, I want to say mid 1995, late 90s, and we have found that synthetic products, along with some ABS materials, when exposed over extended periods of time. When I say extended periods of time, I'm saying 3 to 4 years with 24-hour, 7 days a week, 52 weeks all the year usage, you'll see a degradation of the ABS and also out of that synthetic media itself. So we recommend a fine fiberglass media, and then along with not directly having that UV light shine into that filter itself. So if it's pointed directly towards the evaporator coil, if you have a downstream final secondary filter, you're safe. And then upstream, as long as that light's orientation is towards the evaporator coil or the condensate tray, we're in good shape as long as we maintain part of that preventive maintenance process is inspect that filtration bank while you're going in on your routine quarterly or biannually maintenance program.
And most people don't put UV in the same section with the filters. Usually that UV is in another section of the air handling unit. In that, in 95% of the cases, protects the pre-filter and the final filter because you're having to go through at least a coil to get to the filter between the light. So
yep.
If you've got it in the return duct and the UV lights are in the return duct and it goes around the corner, then the deterioration effects of UV are not going to affect the filters. It has to, for a UV light to deteriorate a filter, it has to be in an immediate line of sight.
Got it. Well, I guess while you're on the topic of UV, maybe switching slightly to it, but what about air cleaners and maybe other technologies that are out there? Electronic filters, induct air scrubbers, etc. Ionizers.
Right. There's bipolar ionization out there, mm-hmm. And we're hearing very good things. We're seeing that in some of the facilities and hospitals, but it's still adjunct to an HVAC system, right? So we still have to have something to capture the particulate in the air, and what we see is most harmful to the body is that 1 micron and below. So we have to maintain a good capture so that's not airborne and in your breathing space. So it's a supplement to good air filtration, and it's a very proven, but at the present time it's not been peer reviewed. But I'm hearing very good things in the field about it.
Both UV and bipolar ionization seem logically, and this is just talk out in the marketplace. So if you guys could educate us, but it seems to me to be very hard to be very effective in an airstream that's moving rapidly by it. Like UV light is dosage times time. So if air is moving by rapidly, the time on that light is going to be very, very low. So your dosage would have to be off the charts high. Ionization, same effect. I don't know how you ionize air that's flying by. I can understand ionization in an operating room when all the doors are closed and you're really, it's able to take effect. Do you guys, this is just general, again, market chatter, if you will, simple questions that you hear on the street. Can you talk to both of those effects?
Chris, do you want to handle the UV side of that?
Well, from the UV standpoint, it's exactly per the previous conversation. If you want to do an airborne kill, it's a calculation. It's a calculation of what are you trying to kill, your cross-sectional area, your airspeed, or CFM divided by cross-sectional area, and the amount of lamp watts. So yes, it's very much it requires math. Yeah. With regard to the other product lines, they are all referenced within the ASHRAE guidelines, but the problem is all of the research that we're currently doing now, there isn't a manufacturer who makes this product that says, hey, can I call up and get some COVIDs because I want to do some testing on it. Most testing on COVID is done by research laboratories in BSL-3 and BSL-4 spaces. And guess what? They're not testing mechanical equipment. So I can tell you there's anecdotal evidence that those products do work. We've got customers that buy those products, love them. They like the way they like the odors they remove. They like the particle arrestants. There are some of those products out there that actually have actual Merv ratings. That's so here's the product and service, and here's the actual tested in a lab Merv rating. The issue is when you get into biologicals, there isn't a testing lab for biologicals. That testing lab is the CDC or a research laboratory at a university, and the manufacturers don't have the time or the resources to test their products against viruses of a specific type. The reason the UV works is because most of it's all physics based, and they can put it into a math model to make it work. But for the other products, we see most of them having a fury of anecdotal evidence, and they have actual test results from a lab. But their performance it may or may not be rated in accordance with a standard that ASHRAE promotes. So the technologies are there. Some people swear by them. Some people don't like them. But I think there's value. They work, but having someone who can test it against a specific virus, that information is not necessarily there.
Yeah.
Okay, going back out to the incoming questions again, switching away from UV. Due to static pressure resistance from higher Merv or Hepa, please talk about longer run time of air handlers prior to occupancy as a purge, and possibly longer after occupancy for extra filtration cleaning, prior to the next day. In summary, does runtime provide extra cleaning even approach the effectiveness of a higher Merv level? In other words, running it longer, does that approach the effectiveness of increasing the Merv of your filtration?
So let's just say, for instance, that we had a Merv 8 pleated filter in there. And so there's two ways to really go about cleaning the air, and it's through dilution. So there's a penalty both ways. There's a penalty that the power needed to do cooling or heating at either BTUs removal or BTUs adding. So there's a penalty of bringing outside air in to dilute that area. So there is that cost of penalty, but there's also a penalty by going from, say, a Merv 8 to a higher resistant Merv 13 or Merv 14 filter. So part of the process is looking at the solution of what will your air handler actually physically accommodate. So we have some great products out there. I think Chris referred to a product, a 22-inch bag filter that doesn't require a pre-filter. So you can eliminate the additional static pressure of the pre-filter and use that bag filter as your pre and your final filter. And you can get a Merv 13, Merv 14, or Merv 15 efficiency out of that. So we just need to go back to air changes. So we have to maintain the percentage or the prescribed amount of air changes to be able to change that air in a system in an hour. But so it's based on, CDC has a general guideline of, I think they're saying eliminate demand control ventilation and bring in as much outside as air as possible. And I think I don't agree with that assessment. I believe that the better filtration can do with Recirc can handle that cleaning of the air. But the other option is that outside air, increasing the outside air and doing the purge or the demand control ventilation. So it's sort of a give and take, because you're going to have to condition that air. And if you're down in Georgia and it's 95 degrees out with 90% relative humidity, you're going to be spending a lot of money cooling that air, bringing it into that building. So you're going to sacrifice something. And then secondly, will that HVAC system be able to handle that amount of outside air and maintain comfort levels within the building that's going to be satisfactory to the occupants, right? So a lot of manufacturers, they don't allow you to bring in 100% 95 degree, 90% relative air, because that compressor just won't handle that much load. So once again, it's back to the professionals assessing what you have in an HVAC system, what you can handle from filtration on an upgrade, and what you can actually handle from outside air. So whatever we talk about, we really talk about the total cost of energy or total cost of ownership, and energy is a big component of that system. So yeah, I don't believe that you just go open up your outside air dampers and dump a bunch of unconditioned air into your building just to mitigate risk from that point. It's a total system, and you have to have the professionals assess that to make sure what's best for each individual facility.
So there are products, and Campbell makes products to provide in-room HEPA recirculation. We've gotten many questions about it, and the idea is if you can increase your air change rate in your room, whether you're doing it from the building standpoint or you're doing it within the room with a portable device, the CDC recognizes that when you increase the air change rate, you reduce the hours or minutes required to remove the particles from the space. So I just pushed up 2 links on the chat bar. So if with an air change rate of 2 air changes per hour, it's 138 minutes to provide a 99% removal if you have a HEPA filter physically recirculating in the space. If you have 12 air changes per hour of a HEPA filter recirculating within a space, it's 23 minutes. 50 air changes, 6 minutes. So where Acuity would see a lot of demand for increasing demand and ignoring the demand-based ventilation, a supplement to that would be to provide an in-room HEPA filter to turn over the air in the space, because inherently, as you increase your air change rate, you are going to increase your particle removal mass in the space. So I just put 2 links up there, which are healthcare guidelines, but they also serve for normal space. So if you want to have a clean office, or you have a high occupancy area, you can know with some certainty if you turn over the air in that space, you can clean the space, and it doesn't necessarily have to be outside air.
So basically, too, for supplemental portable air cleaner with HEPA filtration, you basically take a look at your cubic foot of the room, length times width times height, multiply it by the desired air changes. So if it's 6 air changes an hour, and divide it by 60, that would give you your required CFM necessary to give 6 air changes an hour in that desired, say, conference room or office space. So it's a basic math formula, and you can find out what type of air changes you'd be able to achieve, and then reference back to Chris's document to find out what your time would be to be able to get that desired outcome.
Gotcha. We always think of, it's funny or ironic, I mean, we always think of demand control ventilation as putting more air where and when you need it. Not necessarily. I think the ASHRAE recommendation was kind of, it makes sense in one sense of saying, don't reduce air to save energy in this particular case in a pandemic. We've done many of these webinars, but it's also seasonal. Humidity is obviously a big concern, and here filtration is a big concern. Particulate, control. If you have less particles in the air, healthier, cleaner air, less transmission potential. So I think that demand control ventilation, how are you looking at that from an energy efficiency perspective, or providing more air where when you need it? And I think to completely agree with your point, it's really about optimizing the ventilation in the building, based on IEQ measurement and understanding what's happening, and also what are you trying to accomplish, with all these other strategies, a total comprehensive solution, and then having the data to validate that you're actually achieving it, I think is really important. Make sure that strategy is working.
Yeah, from a very simple standpoint, as Chris was just talking about the in-room HEPA filtration, do I need it? Where do I need it? How do I know if I need it? And that ability to have that precise measurement of the particles would help you design that strategy rather than just throw everything at it strategy.
Yeah, so CDC and ASHRAE, during this pandemic, it's some guidelines for that, trying to mitigate risk. But we all know that, one size shoe doesn't fit everybody. So each building is unique to its own. And once again, I reference to go back to the experts in the field, your HVAC professional contractor, along with your air filtration or your sensor guy, your controls guy, to be able to find out what's going to be best fit for your facility on an individual need and usage. So like I said, one size doesn't fit all, and we really have to make sure that we're looking custom per facility to be able to get the best filtration, the best mitigate of risk, and also the best solution when we look at that balance between energy, air filtration, and then the cost of actually doing business. You know, we can't just, it's not like we all have blank checks and we can just write checks every day to be able to cover the bills, but we still have to look at an operational guideline and fit what's going to be best for our long-term goals and objectives.
Yeah, great. I think, Tom, we've got a lot of questions that people want answered, a lot.
Yeah, I'll keep digging. I've been popping them out. I'll keep digging into them if you want.
Yeah, so we should probably go to those.
Yeah.
And with the remaining time, we have to try to get as many as answered as we can. So, Tom, why don't you fire and see what hasn't been answered?
All right, back to the hardware. What options are there for fan coil units serving a hotel guest room, for example, which can only accommodate a 1-inch filter and low pressure drop?
There's not a lot of options there, to be honest with you. So,
Sure. Short answer.
So we go back to that portable Hepa air cleaner for that space within that lobby.
Okay.
So,
but I just want to be clear though. You're saying that there is, okay, it's the low pressure drop. That's why.
Yeah, it's the low pressure drop. It's, you know, that's that, you know, when you get into a Murph 13 product on a 1-inch product, it's going to have a higher initial static pressure, and it's back to, can that fan overcome that additional resistance and still give you the airflow necessary to be able to find the thermal comfort that you desire in that room.
Yeah. There's a few questions around the subject of total life cycle kind of cost, you know, pressure, increased energy efficiency with higher filtration, run time, you know, increased air change rates, the energy side. I think you kind of addressed all of that, but maybe the one part that we didn't necessarily talk about is really the, you know, how judging when to change filters, these higher efficiency filters. I think you mentioned this on a prep call to us. Can you just talk about that, Joe, real quick?
Yes. So ASHRAE tests pleated filters to 1-inch static pressure final, and then final filters, meaning secondary or high efficiency filters, they're tested to 1.5. So that means that's the testing parameters, but that doesn't mean that that's the optimal change out time for that. So if you go to a document, CDC has a document on filtration, and it says National Institute for Occupational Safety and Health, and the recommendation is based off of filter optimization. And what is that filter optimization? It's the cost of the filter, it's cost of energy to move air through the resistance of that filter, and then also the labor to change that filter. So if you take all three of those important parts of filtration and find that mean point, geometric mean, then you're going to find the filter optimization. So primarily we find, like in the Midwest, at 7 cents a kilowatt hour, filter cost, labor costs are all pretty much the same in the Midwest. We find that it's between a 0.8 and a 0.88 final pressure of that filter is the sweet spot to be able to find the best filter optimization. But not only Camfil, but other manufacturers have a product called, or software product called life cycle costing. And that life cycle costing will give you that exact executive summary to tell you when to best utilize change out time of that filter.
Is there any tested electronic filtration unit that is effective on COVID droplets? I've not seen one, but your opinion is welcome. Tested electronic filtration effective on COVID droplets.
I'm going to have to defer that over to Chris, because I've not been involved in any kind of electronic air cleaners at this point in time during this crisis or this pandemic.
It goes back to the previous conversation. I know that a product like a Secure Air has an actual test against a Murph standard, but again, I don't believe that anybody has any COVID specific testing, because it's a biological test. So I don't believe that anybody has it. Full stop.
Okay. How does efficiency change with filter face velocity? Excuse me, how does efficiency change with filter face velocity? So 500 feet per minute versus 250 and less. More efficient or not? And what could a Merv 13 capture at a lower velocity?
So it's the same efficiency, whether you're running at 250 foot per minute or 550 foot per minute. It refers back to the dust holding capacity or DHC of that filter. So once it achieves its rated final static pressure, that's when you need to change that filter out, because then you're going to risk a blowout of that filter. So it really, if you're running at a lower velocity, you're going to extend the life of that filter because it's going to run longer. And secondly, it would be energy consumption. So at 500 foot per minute, if you have a VFD, you're going to run X amount of hertz based on that resistance. And if you're running at 250 foot per minute, you're going to have lower CFM. And what's going to happen is that VFD is going to ramp down, and it might run at 30 hertz instead of 60 hertz. And that's where you're going to see that energy capture of that energy saving. So the velocity doesn't change the efficiency of the filter by any means.
But it sure will extend the life.
Yes, definitely.
Got it.
Can a link or a title for the ASHRAE document referenced on the presentation be provided via email for our use in forwarding to clients? So would you, yeah, I'll tell you what, Joe, if you would send that to me, then I'll make sure that gets forwarded to all of the attendees.
Definitely. So it has both documents in there, the airborne infectious disease reaffirmation, and also the filtration and disinfection document there.
Okay.
And Chris provided the two CDC links. I don't know if everybody can see them or if it's just the panelists.
I think that's just the panelists. Yeah, no, I see that.
So we have to try to get that over to everybody if they want to copy that link.
Hey, so how many folks are on this call, by the way?
Oh, 1,000.
Several million, I heard.
I actually shared those two links with the attendees as well.
Great. Great, Sarah. Thank you.
Can you use analytics to identify the filters being bypassed or not a tight fit? So easy question for Acuity. Yes, we would, as part of particle monitoring, you would immediately know by looking at the particle count downstream of that filter if there was bypass.
Well, here in Georgia, we always use pollen season. So if you've got pollen downstream of the filter, guess what? You've got bypass. So
There you go. Perfect.
That would work on me, that's for sure. I'll be your test guy. Walk in the building.
All right, so wait, there's one. Okay, so even though transmission of a virus from one part of the building to another is not the normal path of COVID, does reducing the number and size of all particles that are airborne in the space affect the number of virus particles that remain airborne in the space for a given amount of time? That's a tough one.
Well, it's basically saying is, you know, well, it's a logic statement, right? So
right.
if the virus can't attach itself to water nuclei or other particulates, and you're removing those particulates, the question is the water nuclei that comes out of our breathing, if the virus is attached to that, will that stay airborne and get transmitted? I think you've addressed this earlier, but I think that's the logic tree that a lot of customers are asking. That's just I think that's one of many questions we've received over the last few months on this topic.
We had a very well-regarded industry expert on one of our previous webinars, and she talked about the relative humidity in your building being extremely important, because if the RH drops below 40% in that arid environment when you exhale, the droplet nuclei, the moisture that the virus is attached to evaporates, so it becomes smaller and lighter and therefore more easily spread around the building. Okay, I apologize if you answered this one already, Joe. I'm going to lay it on you once more. As I was reading through questions, I might have missed this. I know there was conversation around this. Where is the ideal location of UVC light in the air handler system for managing coronavirus, upstream or downstream of the cooling coil?
That's a Chris question.
We historically see the UV lights downstream of the cooling coil. The challenge with that is UV when the air is colder, UV has to work harder when the air is colder. We don't see many installations where they put it upstream, but we put them downstream because that's the dirty side, the cold side of the cooling coil, which is really what we care about when we're doing a coil cleaning application. If you were doing an airborne kill, a warmer environment and a lower face velocity would be preferred. And usually on either side of the cooling coil is going to be your lowest velocity in your system. Once the air gets into the ductwork, it's moving at a higher velocity and you would need more lights in the array. So I don't know if there's any specific data on COVID on pre-coil or post-coil, but historically we see the UV applied post-cooling coil.
Got it. There's a comment here, Joe, I guess this one might be for you, but PTFE and HEPAs cannot be used in humidified air streams where humidifier is upstream of the HEPA. This person says they've had bad experiences with that. We do have a lot of clients. We do a lot of work in animal research facilities. Many of those are humidified. Would you agree with that statement?
I would agree that excessive saturated air will degrade the integrity of the media. So, 98% of those HEPA filters or ULPA filters are a wet laid fiberglass, right? So if you add saturated air to that media, it's going to degrade over time. So yes, that would be a correct statement. We've seen that in hospitals before, where the dew point was really close to the and we were able to, if they were able to reduce the relative humidity by a couple degrees, it decreased that spread between the dew point and RH. So it was actually, when it would hit the surface of the filter frame, it would compress the air and water droplets would then enter into the filter media of the HEPA filter. So yes, if you have saturated air and high humidity, it's not a good formula for HEPA filtration.
So as I think I'm on mute.
No, you're not.
You just put it on mute.
Okay, so the question about HEPA filters and humidifiers, or was the question about PTFE media and humidifiers?
It was about PTFE media and humidifiers.
Oh, was it specifically for PTFE?
It says PTFE HEPAs cannot be used in humidified airstreams.
Okay, so I'll touch on that a little bit. So historically in hospitals, we do have HEPA filtration at the discharge end of an air handling unit, and those air handling units also have humidifiers. So there's two things that can be done to mitigate. What we see is if you put a humidifier immediately in front of a HEPA filter, eventually you will load that HEPA filter with water, and then that filter will fail, that filter will load.
Yeah.
There's two things that can be done. The humidifier can either be mounted upstream of the preheat coil, upstream of the cooling coil, so that the cooling coil acts as a mist eliminator, and it also wrings out some of the moisture before it goes downstream. And at a minimum, the humidifier needs to be before the fan. When you have a humidified airstream and you get the saturation up to the saturation line, you get a little bit of heat gain going through a fan. And once you get a heat gain going through the fan, then you come off the saturation line of the humidified air. So we see this also in ductwork. If you're going to apply a humidifier in ductwork, it needs to be downstream of a VAV box. And then that VAV box needs to be able to heat the air to 80 or 90 degrees. You then inject humidification to get to your zone set point. There's typically a high limit that knocks out at 85 or 90% relative humidity, so that you don't dump fog into a HEPA filter. So there are some ways to mitigate the use of a HEPA filter and a humidifier. But yes, putting a humidifier immediately in front of a HEPA filter is a bad idea.
We've consumed a lot of time for this. There are just 2 or 3 more questions that I did want to address. So anybody who's hanging on the line there, you're welcome to hang on. Anybody needs to drop off, the recording of this will be provided. And if we did miss any questions, I'll make sure we email you, and we will email all the participants the documents about which we spoke here. The next question is, could you provide a cost-effective alternative for filters used in harsh environments, dust, mist, etc.? That looks like your question, Joe.
Right,
No.
right. So, so that's kind of a loaded question to speak of, because, you know, we provide filters in some manufacturing facilities directly above what we consider a harsh environment, which would be their welding and stamping shop. And so, you know, once again, we assess what kind of cleanliness level and efficiency we want to get with. And we have some specific products that are very robust and they're able to be designed around a high humidity. You know, there's a product called a CamFlow XLT that's a great application where there's high humidity. We use it at, as an example, there's a college in Michigan that draws 100% outside air, and it's drawing in the wintertime. It's snow, drifting snow. It's a horizontal inlet. And so we use that product for that harsh environment. There's also, when you get into water, mist, or oil, we do have water and mist oil separating products out there, Echo Moisture Separator to handle that. But with that product, you're not going to get a very high efficient product. So it's design specific. We have a product called a Cam Cleaner. And in some of the manufacturing facilities, we put a pocket filter in there, fine fiberglass, and we put bag loops at the end of it with a holding rod to support the additional weight from the oil or the water. So once again, it's design specific, and it has to be customized for your facility to be able to achieve the outcome that you're looking for.
How pervasive is it that you get air gaps for bypass around the edges of filters in filter rack assemblies in air handlers? Chris, maybe that's more your question. How often?
Yeah, it's absolutely prevalent. That's why HEPA filters, typically every HEPA filter has a gasket on it. It ships from the factory with a gasket because the recognition of the gasket is the sealing surface. When you have ASHRAE filters, typically the gasket is on the frame itself. Typically tracks don't have gaskets because you're just sliding the filter into the track. So yes, in cataloged equipment, leaks are prevalent. Usually they'll have like a little spacer to make sure all the filters are compressed within the track, and that usually gets thrown or lost. And you'll get I've seen as much a 2 or 3 or 4 inch gap going around a filter in a track. Tracks are the least effective. Holding frames are the most effective, and holding frames with new gaskets are the most effective. And on the backside, you have to seal the holding frames on the backside as well. So, but that's when you buy a HEPA filter and in an air handling unit. That's why you have a frame, and that frame has a sealing surface, and that every time you renew the filter, you're renewing the gasket. So yes, it's important.
Are there additional precautions you should take in changing filters if you have concern of virus in your building?
So there's basically ASHRAE's recommendation, our standard PPE practices. So mask with eye protection and gloves. If you choose to use a Tyvek suit, you can use a Tyvek suit. And then recommendation is to, you know, if you're operating that system and you shut it down, there's potential that you have some capture of some live virus in that filter. So then just put it into a garbage bag or a plastic bag, seal that effectively. So you're not just throwing it on a cart and wheeling it through your facility, and then take care of a normal standard disposal at that point. Once it's in the garbage bag, put it into your dumpster or wherever you're disposing of your filters.
In the
Once
seal
again,
bag.
make sure the mechanic washes his hands, and if he is wearing a Tyvek suit, to either dispose of that and standard practices.
I think that is all the questions. So
That's great. I think it's a wrap.
yeah, that's it. So Joe and Chris, thank you very much for participating here. Great to get all these questions answered. I hope we provide a lot of information to everybody listening. And again, we will have an email going out to all participants with the documents about which we spoke here. And thanks again, everybody, for joining us for our webinar series.
All right. Just for next step, I'll make sure that I get those links over to you for the ASHRAE documents.
Great.
Thank you.
Thank you both so much. Really appreciate it.
Thanks for having us.
Thanks for having us.
Stay
Yes,
healthy
thank
and
you.
well.
See you,
Have a
everybody.
great day.